x, we can make the statement then that if angle BDE is equal to x, therefore angle EDC is also equal to x. My reason here being that that's been given there, the statement that ED bisects angle BDC. Okay, right. And then we can see, okay, great. So we've got that there, which means that our next step to try and get to angle ACD and to angle BAC, we'll need to perhaps set up an equation of some kind. So if I look at those angles at A and angle C that I've indicated there, I'm going to shade in this triangle right here. And I'm going to make an indication here. Okay. Which means that I want to see that angle D as a whole. So if angle D1 is X and angle D2 is also X, then that whole angle of D must surely be 2x, okay? Which means it's an exterior angle, okay? And the exterior angle of that triangle is what I'm going to work with. So what I have here, I'm just going to draw it in a darker highlighter, is I have this line here, I have this triangle here, and I have this exterior angle right there. And what is our rule? Our theory states that the exterior angle of a triangle is equal to the sum of the opposite interior angles. Okay, so let me just draw it this way. I basically have the triangle like that, and then I have my exterior angle. So this right here is my exterior angle. And in this case, this exterior angle has been divided into an x and an x. So my statement here can say that therefore angle BDC is equal to 2x, right? But this 2x is in fact the exterior angle of this triangle right here, for which we want to prove that this angle is the same as that angle. What we also can do is we can see later on they're going to give us lengths. We can see that we are also able to use congruency if we need to perhaps prove certain triangles having the same size or the same length. Okay, what we do in fact have here is that we've already proven that these angles are similar with our previous proof. That one, okay, was the shared angle, and that the angles are the same size. Angle B is equal to angle B, the common angle. Angle D is equal to angle A, okay? That's what we've proven here from similarity. Right here, similarity gave us that angle D, this angle in our original triangle, that small one that we used there, is equal to angle A. Look at that. Okay, so now we've got our interlinking step from triangle BDE being similar to triangle BAC. I can make the statement that angle BDE is equal to angle BAC. And therefore, if angle BDE is equal to x, then angle BAC is also equal to x, right? So if that one there is also equal to x, then using my exterior angle of the triangle in my next reason would help me find the measure of angle C. So now it means that angle BDC, which I've already said here, angle BDC is 2x, right? So that angle BDC is equal to 2x will then also be equal to the exterior angle of the triangle ACD, and therefore angle ACD is equal to x, because what is the rule for the exterior? Because angle BDC is equal to the sum of the interior angles, meaning angle A plus that angle ACD. But we've already proven that angle A right here, BAC, that's angle A, BAC is equal to x, right? Because we used the similarity that we've proven. So if this one is then 2x, that's from angle DC, BDC, and we substitute x into the measure for angle A, it means that angle ACD should therefore also be x. Therefore, angle ACD is equal to x. Therefore, we've proven what we've been asked, to prove that angle ACD is equal to angle BAC. Right, little bit of our application work there. Using the fact that we've already proven similarity. Right, now we get to the lengths. So we've got several lengths given here in 7.3. There is the measure for the length DB. DB is here, that's 3. BE, okay, so BE is 2 centimeters, and EC is 6 centimeters. Remember, we've already proven similarity in these triangles. We need to try and figure out the length of DC. Length of DC is this length right here, okay? Right, so if we have DB being 3, and we have BE, which is 2 centimeters, and we have EC, which is 6 centimeters, we need to try and find the length of DC, this length here. Okay, so we've also already proven now that we've got a couple of angles that are the same, right? So if I take this triangle, I'm going to color it in yellow. What I've just proven in my previous answer, look at how we are building on the previous proof. Whatever we've just proven becomes something that we can use to prove the next thing. Now, if I look at that triangle, I should know that that triangle is an isosceles triangle, right? So it basically has the same measure here and same angle there, Therefore, that length is going to be equal to that length. Looks a bit weird now because it's not really the way we want it to look, but it's basically base angles are equal, therefore the opposite sides are equal. Right, now let's make that statement first, right? Because we can't really carry on if we haven't made that statement, and then you'll see how your proportionality plays a role. So I'm going to keep my triangle in my eye here, and I'm going to write on this side. When I look at in triangle ADC, we've already proven that triangle A is equal to angle A is equal to angle ACD, which is equal to x, which means therefore triangle ADC is an isosceles triangle because the base angles are equal. Therefore, our opposite sides would be equal in length. AD would then be equal to DC or CD. Now, with those two lengths equal, I know that I've already actually been given the length of EC. EC has been given as 6 centimeters, okay? And if I use my similarity from the first question, then I'm going to use EC and these lengths right here to help me find out the length of DC, okay? Because DC would be the same length as AD. So why am I focusing on AD? AD is part of a measure right there, which from my similarity will help me set up my sides in proportion. Let's set it up quickly. So the video that I sent before this, I mentioned that little rhyme again in order to help you with the proportionality of your sides. Smiles and eyebrows, okay? Right, so we've proven that triangle BDE is similar to triangle BAC. And as soon as you're working with lengths and missing sides lengths, you know you're probably going to use that proportionality. Let's do our smiles, which allows us to make the statement BE over BC is then equal to, now let's do the eyebrow. There we go, there we go. So that is BD over BA and allows me to equate my last eyebrow, smiles and eyebrows. There's my brow and the other brow. DE sounds really silly, but in maths we need to have silly things in order to remember. So I've done my smile, smile, eyebrow, eyebrow, okay? BE over BC will have the same proportion as BD over BA, which will have the same proportion as DE over AC. Why may I make this statement? What gives me the right to make such a statement? It is because the triangles are similar. Therefore, your sides are in proportion. So now we've made the statement. Now we can figure it out. Right. Let's replace what we have. Do we have BE? Okay, BE is 2 centimeters. Do we have BC? BC. Okay, watch out for BC. BC is not just 2 or just 6. It is the whole measure. So BC is 2 plus 6, 8 centimeters from our given information, is equal to, what am I trying to solve now again? I want to solve AD, right? I want to solve AD, but AD is actually the same as DC. Right, so let's continue with what we have. Do we have BD? Do we have the length of BD? Yes, we do. The length of BD is 3 centimeters. Do we have BA or AB? AB, no, we don't have AB. But can we express AB? What I'm going to do here is I want to express AB, this whole length, which I'll be able to say, let's just call it 3 plus. So this is the 3 here plus AD. Just leave this as AD and add it to the measure of 3 that's been given, okay? So let me just take that away and express that whole length as 3 plus AD. And then I only have one unknown in this little equation. So I'm going to be able to solve for AD out of this equation. And I've made a note on your memo that I uploaded yesterday that you are allowed to use cross products. Think of this as a unit and think of cross products because we have one fraction equal to one fraction, one term equal to one term, which allows me to perform cross products. That gives me 2 times 3 plus AD, and on the other side 3 times 8. And I can now do distributive law, 6 plus 2AD. Just think of AD as X. Treat it like an X in this case. Continue with 3 times 8 is 24. And then we've got 2AD. Now we're solving 24. I bring my 6 from the left-hand side over to the right-hand side, which means my sign has to change. And it becomes -6. 2AD is equal to 24 minus 6 is 18. And now I need to apply my inverse operation to isolate AD. So isolating AD means divide by 2, the inverse of product. 2 times AD divided by 2 will result in AD. What I do on the left-hand side, I do on the right-hand side. Therefore, AD is equal to 9 centimeters. What does that mean? I go back and I see where does that fit in now. AD is equal to 9 centimeters because of my proportionality. Now that I have AD, I've already made the statement that it's equal to CD. Because of my isosceles triangle. And going back to AD being equal to CD allows me then to say if AD is 9 centimeters, therefore CD is also 9 centimeters. Let's go back to the original question and see we had to work out. We highlighted it in pink, the length of DC or CD. DC, it's the same length. What did we use? We used this fact that we've proven similarity. Out of similarity, we made the deduction using our smiles and eyebrows to make that equation, which allows us to solve. This is your big intermediate step here. Provided that you make it very clear, you are allowed to make that statement because you've already proven that those triangles are similar.